Good morning again. Mr. This is back again in another one. Right, today we're gonna look at solving system of linear equation by using elimination or linear combination. So when you're solving a system of linear equation by elimination, make sure that your equation in the system has to be in standard form. Put your equation in standard form so your equation can be organized line by line. So the next thing you have to remember that when you're solving system a linear equation, there are three possibilities. Three possibilities. Either you're gonna find your answer, which are your intersect of that solution. You will find your solution. All right, especially when the slope are different. All right, then the line will intersecting. You will have a solution. All right, which is called when the system is consistent and dependent. So the other way, the equation could be the same. Sometimes you have to simplify them to find out if they are the same. So in other words, they will have the same slope, same y-intercept, though that will be coinciding. In this case, that will be an identity. Then that will be all real numbers. So that has infinitely many solutions. So the third alternative, that the equation have the same slope but different y-intercept, meaning that the line will be parallel. There will be no solution. In this case, it will produce a false statement. It will produce a false statement when the variable are cancel out and you have 0 is equal to 5. That's a false statement. In this case, there will be no solution and the system will said to be inconsistent. So I have a couple problems on the board. So when you using elimination method or linear combination, your goal is to have one of the variable cancel out. In this case, the first equation is 4x plus 2y is equal to 9, and the second equation is minus 4x plus 3y is equal to 15. In this case, I can see the x cancel each other out. Then that's what I will do. So your goal is to have one of the variable cancel out. In this case, the 4x cancel with the negative 4x, then you will end up with 5y is equal to 25. Then I can solve for y. Just divide by 5. In this case, I will see y is equal to 5. Now, since I know the value of y, I can go in any of the other two equations and replace y, and I will be able to find x. So this is 4x plus 2 times y. In this case, y is 5. Substitute 5 for y is equal to 9. Then I will have 4x plus 10 is equal to 9. Subtract 10 on its side. In this case, I will have 4x is equal to negative 1. Divide by 4. In this case, x is negative 1/4. So my solution, since x is the first order paired, and x has to go first, then my solution is negative 1/4, comma 5. Then this is where if you were to graph it, and those two lines will be intersect. This is the solution of the system that will satisfy both equations. I have another one on the other side. In this case, I'm going to look at the equation again, see which variable that cancel out. In this case, I can see that the 8y cancel the negative 8y. So combine like them, that will be minus 2x plus 5x is 3x, right? Minus 8 plus 20 is 12, and divide by 3. In this case, x is 4. Now, since I know x, I can come, then replace negative 2 times 3 plus 8y is equal to negative 20. This will give me negative 6 plus 8y is equal to negative 8. Add 6, add 6, I will have 8y is equal to negative 2 divided by 8. In this case, y is negative 1/4. My solution will be 4 comma negative 1/4. In this case, that's a solution. Then that's what you need to do in this case. All right, a couple one. When I look at those two equations, none of the variables cancel out. So therefore, I have to tweak it. So I'm trying to cancel x. So this is 2, this is 3. I can multiply the first equation by negative 3 and multiply the second one by 2. So that will cancel x out. So when I distribute the negative 3, that will give me negative 6x minus 21y is equal to negative 12. So I'm going to distribute the 2, that will give me 6x plus 10y is equal to negative 10. Now my x will cancel out. So I will have negative 11y is equal to negative 22. In this case, I will divide both sides by negative 11. In this case, y is 2. Now, once I know the value of y, I can go replace in one of the equations. 2x plus 7 times 2 is equal to 4. Then I will have 2x plus 14 is equal to 4. Subtract 14 on its side. Now we'll have 2x is equal to negative 10 divided by 2. In this case, x is negative 5. Since my order pair is always xy, or in alpha order, then my solution will be negative 5 comma 2. This is the point that will satisfy both equations. So in the other one again, when I look at the x does not automatically cancel each other out, the y does not cancel each other out, I have to find the factor. So my goal is to cancel y. So this is 7, this is so like 7, 2. I can multiply by the reciprocal and make one negative. So I will have to multiply this by 2 and multiply this by 7. Make sure that I have one of them negative. That's the way they can cancel out. So I multiply this by positive 2, I multiply the second one by negative 7. So the y can cancel out. So that will give me positive 14, that will give me negative 14, and the y will cancel out. That will give me 6x plus 14y is equal to 30. I'm distributing the 2 by the first equation. Now I'm distributing negative 7 by the second equation. That will be negative 35x minus 14y. Right? That will give me positive 28 when you multiply to negative. Then the y automatically cancel out. Then that will give you a negative 29x is equal to 58 divided by negative 29 on its side. And you will find that x is negative 2. Since now I know what x is, I can go replace it in one of the equations. Doesn't matter which one that you pick. And that will be 3 times negative 2 plus 7y is equal to 15. That will be negative 6 plus 7y is equal to 15. Add 6 on each side. Then you will have 7y is equal to 21 divided by 7. In this case, y is 3. So my solution will be negative 2, 3. That will be the solution of the system. In this case, there exists a solution. We keep moving on. So I have an equation on this side. So I can see the x cancel each other out, the y cancel each other out, and the 6 cancel each other out. then I will have 0 is equal to 0. This is a true statement. That will be all real numbers. In this case, this doesn't have a restriction. It can take any value that will make that solution work. So that will be an identity. So we can go and investigate that. That in this case, that will be coinciding. So if I were to put those equations in slope-intercept form, so if I add y on this side and subtract 6, I'm going to subtract 6 on each side, and I'm only going to add the y. Then you will end up with y is equal to 7x minus 6. That for the first mile. In this case, the slope is 7 and the y-intercept is negative 6. So for the second equation, if I'm solving for y, I will have to add 7x on this side. I will have to add 7x, and I will have y equal 7x minus 6. My second slope will be 7, and my b-intercept will be negative 6. As you can see, this slope are the same, the y-intercept are the same. Therefore, you're doing with the same line. If you were to graph it, it will be line on top of another line. The system said to be coinciding. And dependent, will be consistent dependent. In this case, it's all real numbers. This is an identity. It will accept all of the solution, all of the x values, any x values, any y values will work. So this is infinitely many solution. Will accept anything you throw out. This is an identity. All right. Here, let's see which variable will be easier to cancel out. That I have a 1x, I have negative 2x, so I will have to multiply this equation by 2. So this will be, that will give me 2x plus 6y is equal to 10. So the x cancel out, then that will give me 2y, right, is equal to 5 divided by 2. In this case, y is 5 half. Now I can go and find x, and I will have x plus 3 times 5 half, right, is equal to 5. Now we'll have x plus 15 half is equal to 5. Alright, since many of you have problem in fraction, if you do not have a problem in fraction, the easiest thing to do is to put this over 1, then subtract 15 half on this side, and you subtract 15 half. Then you will have x is equal to that. So in that to be 2, multiply this by 2, multiply this by 2. This will give you 10 half. Subtract 15 half. In this case, x will be negative 5 half. Right? Your solution will be negative 5 half, positive 5 half. In this case, you have a solution. This is where the two lines will be intersect. If you were to graph it, the solution does exist. More equation coming up. So we have this. You can see the y cancel each other and the x cancel each other. In this case, we'll have 0 on that side is equal to 6, and that is a false math statement. In this case, is no solution. So let's see why no solution. If it's no solution, it's because the lines are parallel. So let's put the equation in slope-intercept form to see if they have the same slope and different y-intercept. So let's solve for y in this one. I'm solving for y, I will add 6y on the other side and subtract 6. Then I will have 4x minus 6 is equal to 6y. Then divided by 6. And I will have y is equal to 2/3 x minus 1. In this case, my slope is 2/3 and my b1 is 31. Here, if I'm solving for y, I will add 6x on, I will add 4x on the other side. I will have 6y is equal 4x plus 10 divided by 6. Then I will have y is equal 2/3 x plus 5/3. In this case, M2 is 2/3 and B2 is 5/3. Let's compare the slope. The slope are the same. That definition of parallel line. Same slope but different y-intercept. Then in this case, the system will be inconsistent. There exists no solution to this problem. All right, let's look at this one. All right, the x cancel each other out, the y cancel each other out, and the 5 cancel each other out. Everything cancel each other out. Then you will have 0 is equal to 0. That's a true statement. In this case, it is infinitely many solution. Is it an identity? Many solution. Okay. The system will say to be consistent dependent. In this case, they will have the same slope, same y-intercept. So let's put this equation, let's put that equation slope-intercept. So if I'm solving for y, I will have to add 3x on each side. Then I will have y is equal 3x minus 5. In this case, this slope is 3. My b1 is negative 5. And this same thing here. All right. I will have to add y on the other side because I want my y to be positive, and subtract 5 on the other side. Then I will have y is equal to 3x minus 5. My slope is 3. My b2 is 5, is negative 5. Right? When I compare my slope, the slope are the same. When I compare my b, they are the same. In this case, you have many solutions. This is a real number. This is an identity. All real numbers. This is an identity. So in this case, you have many solutions. The system will accept as many solutions as possible. Resume. I am solving this case. The x does not cancel each other out automatically. The y does not cancel each other out automatically. So I can say I have a negative 2, positive 3, different sign. So if I multiply this by 3, it will give me negative 6y. If I multiply this by 2, it will give me positive 6y. It will cancel out. So I'll end up with 18x, right, minus 6y is equal to 33. When I distribute the 2, that will give me minus 18x plus 6y, right, is equal to 32. So the x cancel each other out, the y cancel each other out, this side is 0, and that will be 55. That 0 is equal to 55, that's a false statement. Right, in this case, the system has no solution. Those a false statement. In this case, the line must be parallel, same slope, different intercept. Let's explore that. If I'm solving for y, I can add 2y and subtract 11, and I will have 2y is equal to 6x minus 11 divided by 2. I will have y is equal to 3x minus 11 half. My slope is 3. My b1 is negative 11 half. In the second equation, I will have 3x on the other side. I will have 3y is equal to 9x plus 16 divided by 3. And I will have y is equal to 3x plus 16 third. Then my slope is 3, m2 is 3, and b2 is 16 third. Let's compare their slope. The slope is 3, they have same slope, but different y-intercept. The lines are parallel. The system are said to be inconsistent. There will be no solution. If you graph them, they will not touch. Two parallel lines do not touch. They will be equidistant from each other. In this case, there is no solution. Go to the first statement. 0 does not equal to 55. When we put it in slope-intercept form, we compare their slope. We find out the slope are the same, and the y-intercept are different. That the definition of parallel line. Two lines are parallel if and only if they are the same slope, different y-intercept. We have proved that here. All right, here. So let me see if I can cancel the x. So to cancel the x, I will have to multiply this by negative 2. Then that will give me negative 6x minus 4y is equal to negative 20. The x cancel each other, the y cancel each other. That will give you 0 is equal to negative 5. Once again, that's a false statement. No solution. Alright, so we're gonna compare again to see if they have the same slope, different y-intercept, then to prove that those two lines are parallel. So if I'm solving for y, I will have to move 3x on the other side. I will have 2y is equal to negative 3x plus 10 divided by 2, and y is negative 3 half x plus 5. So my slope is negative 3 half, and my b1 is 5. Like in the second one, I want my y to be positive. I'm going to add 4. I'm going to add 4y on the other side. I'm going to add 4y on the other side, and on this side. I will have negative 6x plus 20 is equal to 4y. Right? And divide by 4. And in this case, I will have negative 3 half x. In this case, my m2 is 3 and negative 3 half. Compare this slope. Yes, indeed, they are the same. So in this case, they will be parallel. There is no solution. Right. And this equation, I can see that the y cancel each other, so I can go cancel the y, so I will end up with 2x is equal to 12 plus 2 is 40, divided by 2, and x is 7. So I can come here, the first one, 7 plus y is equal to 12, just subtract 7, in this case, y is 5, so my solution is 7, 5. 7, 5 is the one that gonna satisfy both equations. That was an easy one. Look at the second one. The a cancel each other out. Then 4b minus 2b is 2. 9 take away 3 is 6. Divided by 2. In this case, b is 3. So I can come here. 3a plus 4 times 3 is equal to 9. I will have 3a plus 12 is equal to 9. Subtract 12 on each side. Then I will have 3a is equal to negative 3 divided by 3. In this case, a is negative 1. Since I'm using a and b, so that's in alpha order. My variable that comes first is same thing as my x. They say variable that follows second as my y. Actually, when you solving your equation, if it's not x and y, your solution has to be in alpha order. So whatever letter that comes in the alphabet is your x. The one that follow is your y. In this case, my solution is negative 1, comma 3. And that is the solution of the system. That's what will satisfy the system. More solving our system of linear equation. In this case, it will be easier to cancel the y. However, both of them are negative, so I need to make one of them positive. So I will multiply the first equation by negative 1. So that will give me negative 5x plus y is equal to negative 4. So I will end up with negative 3x. The y cancel each other out is equal to negative 3 divided by negative 3. And I will find x is 1. Now since I know the value of x, I will have 5 times 1 minus y is equal to 4. That will give you 5, right, minus y is equal to 4 minus 5 minus 5. I will have negative y is equal to negative 1 divided by negative 1. Y is 1. So my solution is 1, 1. 1, 1 is the order that satisfies both equations. So when I go in the other equation, when I look at it, and I notice that both variables, the s cancel each other out. So I will have 6r is equal to 12 divided by 6. In this case, r is 2. Since I know the value of r, I can come replace it in the first equation. That will be 2 times 2 plus s is equal to 3. I will have 4 plus s is equal to 3. Subtract 4 on each side. Then I will have s to be negative 1. So those are my solution. By rs, that will be 2, 1 alpha order. This is the solution of the system. I will do a couple examples, then we move on to substitution. All right, back again. All right, wake up, guys. All right, when I'm looking at this equation, I will target to solve for b. So I notice I have a 3b here, I have negative 1b, Therefore, I must multiply this by 3 so I can get my negative 3b. So I will end up with 15a minus 3b is equal to 39. Multiply this equation by 3, multiply everything by 3, and I end up with 2a plus 3b is equal to 12. So I bring this equation down so I can combine them. This cancel each other, and I will have 17a is equal to 51 divided both sides by 17. In this case, a is 3. Since I know what a is, I can come and replace it. That will be 2 times 3 plus 3b is equal to 12. I will have 6 plus 3b is equal to 12. Subtract 6, then I will have 3b is equal to 6 divided by 3. In this case, b is 2. My solution is AB alpha order. And that will be 3, 2. This is the solution of this system. So when I move in this equation, so I can either go cancel d, multiply this by 3. However, I noticed this equation, they have 3 in common. So let me see if I divide by 3, what's going on. If I divide by 3, I will end up with 3a minus d is equal to 1. So this cancel, this cancel, this cancel, this cancel, this cancel, this cancel. I will have that 0 is equal to 0. This is a true mathematical statement. This is a true statement. In this case, it's an identity, it's all real numbers, and finitely many solution. This system is said to be consistent dependent. So that's our lesson on system of linear equation by using elimination method or linear combination, where you have to put your equation in standard form, have your equation in standard form, organize, and target the variable that you want to cancel. Sometimes the variable that cancel each other out. When they not cancel each other out, look for one that has a coefficient of 1 or negative 1 and multiply by a factor so you can get one of the variable cancel out. And sometimes you might be lucky. Both variable cancel out or everything cancel out. When both variable cancel out, you have to be aware what's going on. You have to notice that if it's produce a false or a true statement. If it's produce a false statement, that means there exists no solution to this problem. So you can investigate further by writing your equation in slope-intercept form, compare their slope. If they do not touch, if it produces no solution, it's because the lines are parallel. In this case, translate the equation in slope-intercept form, as many equations as possible, and compare their slope. In this case, you should realize that either they have the same slope, different y-intercept. If they have the same slope, different y-intercept, in this case, it is parallel. However, if they have the same slope, same y-intercept, you are dealing with the same line that's said to be coinciding. In this case, that will be many solution. That will be a system that will be consistent dependent. So be aware of those things. So let's go to the channel, subscribe, like, and share. Mr. Disease.